Okay, so I'm gonna be developing a game for the next couple months, and I just wanted to try and document the process of my thinking in making that game. So, yeah, let's get started. I'm doing libGDX. It's a OpenGL Java framework that simplifies a lot of things. I already thought of a name. I'm gonna call it VGen. This is a result of basically a shortened version of To Thrive, because that should be the premise of my game. So package, let's make it like that. We'll just call this VGen as well. I already have that done. I want a desktop. I want Android. I don't want HTML. iOS, I don't really want to do that. And I want box 2D lights, free type Ashley, box 2D and tools. Free types just for fonts, tools just some nifty things. Box 2D's physics, box 2D lights is cool lights for physics, and Ashley's an entity component system. I'm going to be using IntelliJ IDEA. So let's start generating. Oop. Well, before we start, we should probably make a plan. I'm going to make something called plan. So far, I really haven't given any ideas for my game, and I'll do that a bit later. But right now, let me just go over the structure that I want it to use, which is a model view controller method, or design. And that basically says you have a model, which is where you store logic, information, etc. You have a view, which is responsible for rendering. And you have, actually, this is just store information, my bad. You have a controller, which controls and alters information in the model. Basically, acts upon models. Oop, too many spaces there. So I added this picture here just so you could see it a bit better. Basically, me, like the player of the game, sees what's in the view, and through input methods like keyboards or mouse clicks, they go to the controller, which then sends handling information to the model, which handles those events. And right now, I just want to work on the model really quickly. Won't take too long. But in order to do that, we need to go over entity component systems. In this case, I'm using Ashley, which there's a couple other ones. There's Artemis and some other ones. I can't remember. But basically, entity component system, the principle behind it is separating logic, like really separating logic, as in like every piece of logic has its own class. Separating logic. No, it's not that much. But anyway, entities are basically like a storage of components. Components, storage of information, and systems act upon component information. For example, there might be a player entity, which has a position component. There might be a movement system that acts upon anything with a position component. It would get that through like a get method for all the entities that have a position component. And then it would go like increase x++ or like y++ or something. And because the player entity depends on the position component and the system alters the position component, the moving system is updating the entity without knowing what the entity is. And that's a term called decoupling. decoupled in this case. Anyway, very somewhat simple. It's a little hard to get into it. But let's go into rendering. We're going to work on the view. Oh, not model. What was I talking about? The view. That's basically just rendering. Okay. So, I want there to exist a render component. Inside that render component, you'd have a sprite. And yeah, I think that's it. I want to have a render system that'll take in a render component, or the acts upon render component acts upon entities with a render component, comma, position component. Let's go up here and add a position component. And this will have a vector3 called position or pause. Okay, so in that render system, it'll have some logic that'll basically say for each entity with render component and position component. Oh, render system will have access to a sprite batch. And a sprite batch is basically just like a group of an object that holds a group of sprites that renders all those sprites in one draw call. So instead of rendering or doing 1,000 draw calls, it's just one draw call that batches all the sprites into one. Something like that. We're gonna do for each entity component or entity with render component. Whatever. Draw a sprite at pause. Yep, that should be it. Okay, as you can see, I did quite a bit of work on the render system, which I detailed earlier, and the end result is something like this. It's not much of a change from the original version, which is just red in the background and has this guy a bit like over here or something. I forgot. But I actually made quite a bit of changes to everything, and we'll start in the main class. So for starters, usually when you generate something, it extends application adapter, but I changed it to extends games. That's because game has certain methods that I would like to call, namely set screen, which will show the screen, and it has a reference to the main screen right there. And this is also an application listener, which is not exactly an application adapter, but they're basically the same thing. I can make a new screen. In order to implement all that rendering stuff, I need to go to the screen implementation to set everything up. So that's what I did. I made a game screen class, which I'll go over, and I set screen to that screen, which means it'll call show on that screen. Now to render, all I need to do to get this screen is just reference it, because it's a protected class, and this extends it, so that means you can get it. Dispose method, nothing much changed. I just added a return batch, a getter, because I like to keep my variables private. Let's go to game screen. Okay, so I have a reference to my game. It's a final variable because it won't change no matter what. There's only one instance of the game running at once. I don't really have a use for it yet, but it might come up. I have a sprite batch in here that gets set to the game batch. I have a class called view handler. This is where I'm going to take care of orthographic camera and viewport kind of stuff, even maybe some shader kind of stuff. This is basically where I'm handling anything that has to do with the view. So I have an init method. I like to use init methods because they're separate from the constructor. So it's a different way of dependency injection. I have an update method which basically takes in a batch and applies the projection matrix that it gets from the viewport, which is right there. Resize, which tells the viewport how big everything is supposed to be. And a set camera position, where it basically just takes some vector 2 in, because it's a 2D game, and sets the camera position to that and updates it. Okay, let's get on to the meat of what I've done here, and that comes with game controller right here. So it has an init method, and it has this method, which is in my show method, which is like the game screen's init method. So let's get into game controller. So game controller, this is where I finally start using Ashley, the entity component system I talked about before. So engine is basically what holds models and components and such, like systems and entities. So here I initialize the entity, and I make just a temporary, or initialize the engine, and I make a temporary entity called player, where I init it and then add it into the engine. If we take a look at player here, it's just an entity, and it has some components here. A position component, like I said, a render component, and you can ignore this. This is just for messing around with the camera. But in the render component, let's take a look at that. It basically just takes in a sprite and has an instance field, which is a sprite. So right here, I just put a sprite to the default picture that libGDX gives you. Alright, so on its update method, I just update the engine, which will update all the entities and systems in the engine. If you noticed in my game screen, I add this render system, which takes in a batch. So this is where the whole design pattern or design comes in. So basically, in this render system, it extends iterating system, which basically means that each time the engine calls the update method, the system will retrieve a list of entities with all the components I've specified right here. So it goes like, okay, get all the entities within my engine with these two components, position and render component, because I need those two components to render in the render system. I store the batch right here, and the process entity method, which is called on each entity that the system retrieves, I get its position component through a mapper. This is a component mapper is basically like a hash map that has a blazing fast O1 access time to any entity with the specified component. That means that if I have any entity at all that has a position component, all I do is pass it in to this guy. So if I pass in that entity to this component mapper, it'll return the position component, or the component, like respective component. So right there, pm.getEntity, and it returns me that entity's position component. Now that I have its position and render component, I did this just to be clean. I took the sprite, the position, and the width. The width, because of how the viewports work, I have to divide it by my pixel per meter measurement. And I just draw it. And the end result is what I showed you before. Yeah. Okay, let's get into this last thing right here. I commented it out before, but it's the camera focus system I made. So if we take a look at the camera focus system, it basically says, it takes in my view handler, which has, as you know, references to the orthographic camera and the viewport. And it basically requires a camera focus control and a position component. Camera focus component. Okay, so that means that this is basically saying, hey, focus on me. And this is basically saying, here, this is my position. So then I just take its position component and then set the camera position, this function right here, which I did right there, where I just get the camera and then set it. I could even lerp it, linear interpolation, if I wanted to, like that. But I'd like to just set it. And I update it. And that's it. Every single time, it's an iterating system as well. It'll find whatever one has a camera focus component, and then move the camera to that. Alright, so that's my game right now. As you can see, the picture is centered because the center is 0, 0 in terms of viewports. So that means its camera position is at this guy's position, which makes the relative position 0, 0. Its real position should be like, or its starting position of the camera should be like somewhere over here. So yeah, that's all I've done in the last day or two. This really didn't take too long, so hopefully I should be able to have more progress for you guys next time. But that's it.